Hello everyone and welcome back. In this video, we're going to explore topic 5.2 Extreme Value Theorem, Global versus Local Extrema and Critical Points. Now, extrema of a function. In calculus, we need to determine if the function f has a maximum value on the interval I. If the function f has a minimum value on the interval I. When the function f is increasing, when the function f is decreasing. Alright, so throughout the unit, you will use the derivatives to answer this question and more than apply them to real life situations. Alright, a function does not have to have a maximum or a minimum on an interval. For instance, in figure number 1, which is right here, you can see that the function f(s) equal s squared plus 1 has both maximum and minimum on the closed interval -1 and 2. Right? This one is the maximum. This one is the minimum. Right? Now look at the figure number 2. You have no maximum, but you have minimum, right? It's gonna be right here because the function is continuous right here. But right here, you see that this one is the whole, right? So the function is not defined by this one, right? So there is no maximum. Now look at the picture number 3. There is a maximum right here, but no minimum because the function is discontinuous right at this point, right? Now, the following theorem is a result from the situation to the left, the extreme value theorem. If the function f is continuous on a closed interval a and b, then the function f has both maximum and minimum on the interval. Right? Now, we're going to talk about the local, which means relative, or global, which means absolute, maxima, or minima. Among other local, relative, maxima, or minima, the greatest local or relative maximum is the global or absolute maximum, and the least local relative minimum is the global absolute minimum. Alright, actually you learn this one in AB pre-calculus. Alright. So we look at the following pictures right here. This guy has the local mass of -1 as s equal -4 and local mass of 2 when s equal 3, right? This guy also has the local mean of -4 as s equal -1, right? Now we need to find the absolute mass and mean, right? So look at this one. The greatest local mass is the global mass, right? So the greatest is right here. So this guy is the global mass, right? And the function has no absolute mean, right? Because this guy keep going forever, right? Now look at the picture number 2. The local mass is right here, -1 as s equal -5, and right here, it's going to be -1 as s equals 1, right? And the function has the local mean, it's going to be right here, -5 as s equals -3, right? Now we're going to talk about the global mass. The greatest local maximum is the absolute maximum, right? The greatest is -1 right here. So this one is the global mass, and the function does not have the global or absolute minimum, right? Now number 3, the local mass is right here, 3 as s equal -2, right? And this guy right here, negative 1 as x squared 4, right? Now the function has local minimums right here. Excavate negative 6 as x squared negative 5 and negative 3 as x squared 2, right? Now we're gonna check for the absolute maximum. Absolute maximum actually this guy right here, right? X could be 3 as x squared negative 2 and absolute minimum is gonna be right here, right? Negative 6 as x squared negative 5, right? Now let's move on to the next one, relative extrema and critical numbers. The graph of f(s) equals x cubed minus 3x squared to the right has a relative maximum, which is right here, right? And relative minimum, which is right here, right? To make this easier for you, think of the relative maximum as being a peak of a mountain on the graph and the relative minimum occurring as the valley of the graph, right? Note that if these peaks and valleys have smooth rapid curves about them, then the graph has a horizontal tangent line at those points. Note that at each relative extrema, the derivative is either 0 or does not exist. The x values at these special points are called critical numbers. Definition of critical numbers. Let the function f be defined as a value c. If f prime of c equals 0 or if f is not differentiable at c, then c is called critical number of the function f. Definition of relative extrema. Let f be a function whose second derivative exists on an open interval I. If there is an open interval containing the value of c, on which f of c is a maximum, then f of c is called a relative maximum of the function f. If there is an open interval containing c, on which f of c is a minimum, then f of c is called a relative minimum of the function f. The plural of relative maximum is relative maxima, and the plural of the relative minimum is relative minima. Below are two examples of a critical number c of the function f. Now look at this one right here. The function has a sharp turn, so f prime of c does not exist. Then c is a critical number of the function f. Now f prime of c equals 0 right here. The function has a horizontal tangent line, right? Relative extrema occur only at critical numbers. If the function f has a relative minimum or relative maximum at x equals c, then c is a critical number of the function f. Alright, now let's look at example number 1. If f is continuous on the closed interval a, b, and differentiable on the open interval a, b, which of the following could be false? A. F prime of c equals f of b minus f of a over b minus a for some c such that c between a and b. This one always choose by the mean value theorem, right? Now, answer choice B. F prime of c equals 0 for some c such that c between a and b. This not always true, right? By the rho theorem, f a must be equals f of b, right? So this one is false. Question C and D. The function f has a minimum or maximum value on the closed interval a and b. This guy always choose by the extreme value theorem, which we just learned right here, right? It's right here. The final answer must be B. cứ say false. Now example number 2. The function f is defined on the closed interval 0 and 1 and satisfies f of 0 equals f of 1 half equals f of 1 on the open interval 0 and 1. F is continuous and strictly increasing. Which of the following statements is true? A. F attains both a minimum value and a maximum value on the closed interval 0 and 1. Question B. F attains a minimum value but not a maximum value on the closed interval 0, 1. Question C. F attains a maximum value but not a minimum value on the closed interval 0, 1. Question D. F attains neither a minimum value nor a maximum value on the closed interval 0 and 1. Alright, so go let's get this picture, right? So I have f of 0 equals f of 1 half equals f of 1, right? So it's going to be right here, and right here. This one is 0, 1 half, and 1, right? Now, on the open interval 0 and 1, which is from here to here, the function f is continuous and strictly increasing. Be careful, this one open interval 0 and 1, the function f is continuous and strictly increasing, right? So the function is undefined as 0 right here, right? And 1 right here. So it could be something like this. Right? Be careful. This one is closed interval. You have this guy. On the open interval, you have two holes right here. Right? So the function f is discontinuous on the closed interval 0 and 1. So if it's discontinuous, it doesn't have maximum nor minimum value, right? So the answer must be D. Now let's take a look at example number 3. Let g be a function given by g of s equals s squared times e to the ks, where k is a constant. For what values of k does the function g have a critical point as s equals 3.5, right? So the first thing you need to do is to take derivative, right? I'm going to use the product rule, right? So remember u times v prime. It's going to be u prime v plus v prime u, right? So it's going to be 2s times e to the ks plus, now e to the ks is e to the u, right? Prime is going to be u prime times e to the u, right? So it turns out to be k times e to the ks times s squared, right? Now we know that the function f has a critical point as s equals 3.5, right? So you have g prime of 3.5 right here must be equals to 0, right? So this guy is the same thing as substitute 3.5 for s into this guy right here. So have you just solve the equation for k, right? So this guy cancel out. So I'm gonna factor e raised to the 3.5 k out, right? So I have e raised to the 3.5 k. It's gonna be 3 plus 9 over 4 k equals 0. Now keep in mind this one always positive, right? So I don't need to worry about this guy, right? So I only need this guy to be 0, right? So I have 9 over 4k equals negative 3. K equals negative 12 over 9. Or k equals negative 4 over 3. So the answer must be A. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.